Hello and welcome back to sqatutorials.com, and today what I want to do is I want to have a quick look at a question 5, and I want to go through how to calculate an azimuth. And what I want to do is I want to show you how I do it. So yours may be different, but this is how I do it. So the first thing I'm going to do is, having a look at the question, I can see that we are dealing with a planet. In the February 2026 paper, we are in evening twilight of the 23rd of January, and the officer of the watch is observing Venus. And so we're going to compare the gyro and the compass readings in order to get a compass error. Now, what I prefer to do is I prefer to do the whole calculation and then give all the answers at the end. That way my concentration isn't interrupted, and I find that works better for me. So this is question 5. This is in 4 parts, and it is a simple azimuth. So that being said, I write all the information down. We know we're talking about Venus, and we know that the bearing of Venus is 273 degrees gyro, but it is also 282 degrees compass. The variation is 8 degrees west, and our DR position is 3642 south and 132.39 west. What else do we know? We know that our chronometer is showing 5 hours, 31 minutes, and 42 seconds. There's an error of 1 minute and 5 seconds, and it is fast. So there's all your information. I prefer it here, then I don't have to go back to the question. Now, the first thing that we have to do is we have to find out whether this is 0500 on the 23rd or 1700 on the 23rd, or whether it's going to be on the 24th of January. So I didn't write the date down. Let me write the date down. 24th of the 3rd. Okay. So in order to do this, I'm going to need to find an approximate time. And what I'm looking for is I'm looking for an approximate GMT. So my approximate LMT of twilight is going to be on the 23rd at whatever time it is from the almanac. It doesn't give us a time in the question, so we need to find that. We need to use an approximate LIT. For 132.39 minutes. And then we're going to find an approximate GMT. Once I've done that, I'm going to end up with a chronometer date and time, and I will apply my error, which in this case is going to be subtractive because it's fast, and then I'm going to end up with a GMT. So that's the general sequence. So what I will do is I will just make this nice and pretty for you. And then we'll be in a position to go. Now I do like to pre-calculate everything. So I'm going to carry on with my performer, and then I'll do this first, actually, what I'll do. So first step is to go into the almanac. Almanac for the 24th, 23rd, January 23rd. There's the 23rd of January, and we're told it's the evening twilight. That means it's going to be down here. Now you will notice that I use a ruler for this because I think that way I don't make a mistake. So what am I looking for? I'm looking for the latitude 3642 south. So there's south 36, there's 35, and we're looking at civil twilight 1942 and 1956. So this is only an approximation, so I will take the 35. So for 35 south, the twilight is 1942. So put that there. Oh, don't miss it. Don't lose my place. So we know that it's going to be 23rd at 1942. Just an approximation. Doesn't have to be more than that. So now I'm going to apply my longitude in time, which is 132.39, 132 degrees, 39 minutes. I'll divide that by 15, and that's going to give me a longitude in time of 8:51. So that's 8 hours and 51 minutes. Longitude west, Greenwich best. So we're going to add these two. And I like to put the sign there to show the marker that what my intentions are. So that being said, let's take that and we'll add 1942 onto that. Well, I can do that. Plus 19.7 equals 20 minus 24. It's going to be 4 hours and 33 minutes. So that's going to be the 24th at 04:33. So the approximate GMT, the GMT date is the 24th at 04:33, which means for my chronometer that this is probably going to be at 05:31 on the 24th. That is the date that I'm going to use for this. So it's going to be the 24th of the 1st at 05:31:42 seconds. I'm going to subtract my 1 minute and 5 seconds, and that's going to give me the 24th of January at 05:37. So that is the time that I'm going to use now for my calculation. So first thing I'm going to do is I'm going to go and find the GHA of the planet, which is Venus. And that's going to be for the 24th of the 1st at 05 hours. I'm going to apply an increment again for Venus, and that's going to be for 30 minutes and 37 seconds. There's going to be a V correction, which I'm going to need to apply. And then to all of this, I'm going to apply my longitude, which in this case is westerly, so that's going to be subtractive. And then finally, I'm going to end up with my LHA of Venus. When I derive this from the almanac, I'm going to go and find the declination of Venus, whatever it is, and there is going to be a D correction that needs to be applied, and then I'm going to end up with my corrected declination of Venus. That's the next step. Now, once I've obtained these values, what I'm going to do next is I'm going to find my A, B, and C values. So I'm going to prepare my worksheet to show that. So the next thing I would do is I would go A, which is equal to the tan of the latitude divided by the tan of the LHA is going to give me whatever it does. There's my A value there. B is going to be the tan of the declination divided by the sine of the LHA, and that'll give me my C value. The algebraic sum of these two is going to give me my C value, and then my azimuth, my true azimuth, is going to be the arctan of 1 divided by C times the cosine of the latitude, and that'll give us a value in quadrantal notation. That is how far I'm going to go for now. So step 1 is to go into the almanac and take out these values. So here we are back in the almanac, and I use a ruler. It's the 24th at 0500 hours. So we've got 24th. There is this column over here is Venus, and there is a V correction at the bottom and a D correction to apply. So first value I'm going to put down is the GHA of Venus, which is 206.39.1. There are other things that I need to do. Declination, for example. Declination for 05 is going to be south 3, 21.1 minutes, and it is decreasing, which means my D correction is minus. South 3, 21.1. So south 3 degrees, 21.1 minutes. The D correction is 1.2, and the V correction is 0.2. So that's 0.2, and this is 1.2. This is going to be subtractive because the trend was decreasing. So next step is to go into the increment table for 3037. So there is 36, there is 30 over there, and for the 3037, there's 3037 is 739.3. 7 degrees, 39.3 minutes. My D correction value is 1.2, so that's going to be 0.6 from there, minus 0.6, and the 0.2 value is additive in this case, and 0.2 is going to be 0.1. So that's 0.1 minutes. So I'm now finished with the almanac, and now I can go ahead and do this. So this is going to be minus 0.6. That's going to be south 3 degrees, 20.5 minutes. I have to insert my longitude 132.39, which is there. And then I'm going to do the sum. Now, I'm not going to, this is such a small value, I'm simply going to add this to here and apply it as one value, just to save time. So I'm starting with my GHA, 206 degrees, 39.1 minutes, plus 7 degrees, 39.4 minutes, added that 0.1 to there. I'm going to minus 132 degrees, 39 minutes, and that's going to give me an LHA of 81 degrees, 39.5 minutes. 81 degrees, 39.5 minutes. So the next step, I have that. I'm now going to find my A value. So the tan of the latitude, it's going to be the tan of 36.42 minutes, tan 36 degrees, 42 minutes, divided by tan of the answer equals, and the value is 0.10929. So now we need to name this. We need to use the names because you can't use the signs that the calculator gives you. So it's always named, the A value is always named opposite to the latitude, except where the LHA is between 90 and 270. In this case, the LHA is not that, so it's named opposite to the latitude, which is south, so this is going to be a north value. The declination will always take the same name as the declination, always. So this is going to be a south value. So now I'm going to calculate the difference between the two, B value. So I'm going to go, B is equal to the sine of the tan declination divided by sine LHA. So it's going to be tan 3 degrees, 20.5 minutes, divided by the sine of the LHA, which was 81 degrees, 39.5 minutes, close brackets, equals 0.05901. So you can see that this is smaller than that, so we need to subtract the 2. So it's going to be 0.10929 minus answer equals 0.0528, and it'll take the name of the larger quantity, which is north. So my azimuth is going to be north something. Now we come over here to find out east or west. If the LHA is less than 180 degrees, then the body is setting, and the body sets in the west. So this will be northwest. If it was greater, it would be rising. So now all I have to do is convert that into a value. So that's what we're going to do next. So there's my C value. I'm going to multiply that by the cosine of the latitude, which is 36.42, 36 degrees, 42 minutes, equals 1 divided by answer equals shift tan answer equals. So it's north 87 degrees, 0.69164. So that's a decimal value, but we need to render these things according to the guidance to the nearest half degree. This is closer to 0.5 than it is to 0.75. So what I'm going to do is my true bearing of Venus is going to be something, so I'll take that away from north. So 360 minus answer is 272.3. The nearest one is a half. So 272.5 or 272 and a half. 272 and a half degrees true. Now here I'm going to do my gyro. Here I'm going to do my compass. So I'll just do the gyro first. So the gyro bearing, we were told, was 273. And that means that our gyro error is a half a degree. Gyro is reading higher than the true. So it's a half degree high. Now, here, this is an interesting little thing. In the most recent marker report from the chief mate's examinations, candidates were penalized if they showed their gyro error as anything but as anything but a half or 0.5. And the reason for this is because we can't apply anything more or less than a half degree. So my advice to you is to follow the guidance, and the guidance says quite clearly that you have to show this to the nearest half degree. So you either do it as 0.5 or you do it as a fraction, as you can see here. Now I'm going to do my compass error. So my true bearing is 272.5 degrees. The compass bearing was 282 degrees. Compass. That means that my compass error is the difference between those two. So it's going to be 282 minus 272.5 equals 9.5 degrees. So there's 9.5 degrees. Error west, compass best. So this must be westerly. So this is my compass error. To this, I'm going to apply my variation, which was given to us as 8 degrees west. And from that, I'm going to determine my deviation. Now, in any compass error, the variation and the deviation applied together must give you the compass error. So this value over here must be the difference between these two, because this is 8 west, this is 9.5 west, so whatever this is, this plus this must equal that. So in this case, our deviation is going to be 1.5 degrees west. Now you can do it the other method. I choose not to. I think this is a better way of doing it, and I think that it shows your knowledge of the principle. So that being said, I said to you that I was going to give all my answers in one go. So because I didn't want to interrupt my train of thought. So here we go. Answers. A, we were asked for the GMT. So the GMT was the 24th of the 1st at 05:30 minutes 37 seconds. B, we were asked for the true bearing. So body, which was Venus, was bearing 272, 272.5 degrees true. And for part C, we were asked for the gyro error, which was half degree low. It was half degree high. And then D was the deviation for the ship's head, and that was 1.5 degrees west. So only one thing that remains, and that's to box it off beautifully so that it catches the attention of your marker, who will see this and who will then give you full marks, providing you've got it right. There we go. The key things to remember when doing a planet is that we need to apply the V correction. Your declination needs to apply its D correction, and then you do the azimuth in the normal way. Now, in this particular case, this was set at evening twilight, and one of the things that you need to be absolutely certain about is that if we are talking about a body other than the sun at twilight, well, then it's going to be an azimuth rather than an amplitude. I'm sure many students will have looked at this and seen the word twilight and then decided that this was going to be an amplitude, which of course would be wrong. So that's it for now. Head on over to sqatutorials.com, where we will have the whole paper done in video for you. So thank you for your time, and we will see you next time.